Alright, so for tonight, I decided to do another transposition for a typical format of determining oxidation states. Usually with oxidation states, you add up the species and then you make it equal to the overall charge of the compound, ion, whatever you're looking for. And most times, if you have a neutral compound, it would equal to 0. The overall charge will be 0. And if you have a charged species, you make that equation equal to the overall charge of the species. Usually, you have an A plus B relationship to give a C. And if you're looking for A, in this case, you have the A in the brackets, you're going to simply minus B from the left and minus B from the, whatever you do to the left, you do to the right, and you get rid of that. So you would have A equal to C minus B. Same thing goes if you have A minus B equals to C. The same, you would just add B. If you're looking for A, you want to get rid of A, you want to get rid of B. That's on the left side, so you would just add B to the left side to get rid of it since it was minus, and you would add it to the right side because you did it to the left. And your answer would be A equals to C plus B. And for the bottom one, we have another relationship where sometimes you will have a species multiplied by its variable. So you have AX plus B equals to C. And if you're looking for A, you want to get rid of the species B first. So you do the same thing you were doing all along. You would, since you have a positive B, you would just minus it from the left and minus it from the right as well. And then because it's a multiplication where you have AX, you have to divide to get rid of X. So you would just divide AX by X, and the same thing you do to the left, the right side, and they will have A is equal to C minus B over X. And that's basically a wrap. If A had AX minus B equals to C, you would have simply added B instead of minus B, and you would have had C plus B over X. Same thing you learned above is what you would just transfer in with your knowledge to work out the last question. So now that you have done a crash course in transposition for the typical form for determining oxidation states, we could do this. Now, determining the oxidation states of species. MnO2 is equal to, usually you add them like I said, and since we have one Mn, you just write Mn, and we have two O's, so we multiply the oxygen by 2, and the overall charge, because there's nothing here above it, it's 0. It's a neutral compound. So in other words, now that the one that is underlined, you always denote as X or whatever letter you want to give. It could be A, it could be P, but in this case, for simplicity's sake, we use X. And here we have X plus 2, and we know the charge of oxygen is usually -2. So we multiply it by -2 equal to 0. And from what we learned a while ago, X would therefore equal to +4, because this is X plus -4 to equal to 0, and the negative would override this. So then when you bring it over here, you would add this here, and you would add this here, and therefore X is equal to +4. Now we have the dichromate anion. We have 2 chromate atoms, we have 7 oxygen atoms, and the overall charge this time is 2-. So we have our equation set up with the equals to -2. Now, since we're looking for chromium, all we're going to do is put it at an X. So you would have 2 times X plus 7 times -2, because oxygen is a -2, equal to -2. So 7 times -2 is actually -14, right? So therefore you would have 2x equals to -2 plus 14y, because to get rid of this, you have to add 14, and you add 14 here. So it goes away. So now that you have your 2x equals to -2 plus 14, right? 14 minus 2 is 12. And since this is 2x, you divide by x here, sorry, you divide by 2 here, and you divide by 2 here, because you need to get rid of the 2 to have x alone. So x is equal to 2 into 12, which will give you positive 6. Alright, this sounds about right. We have sulfuric acid here, H2SO4, and we're looking for the sulfur atom. So we write out our equation again. We have no charge above this. So we have 2 hydrogens plus sulfur plus 4 oxygens to give an overall charge of 0. So we're going to have 2 times 1, because the charge of hydrogen is 1 plus 1, usually plus 1, plus x plus 4 times negative 2 to equal to 0. Now we know that 4 times negative 2 is negative 8, right? So we would have now x is equal to 0 plus 8, because we have the plus 8 here, right? And this would be no, because this is positive 2, with minus 2, because we need to get rid of this, and everything we do here, we do on the next side, which is what we did. So 8 minus 2 is equal to, you got it, plus 6. And oxidation is so easy. So here we go, H2O. We're looking for O. We have two hydrogens plus oxygen, and overall charge of 0, because it's a neutral compound. So therefore 2 times 1, which is the charge of hydrogen, plus x, because we're looking for oxygen, is equal to 0. So therefore we're going to have, if this is 2, so it's 2 plus x equal to 0. We want to get rid of 2 over here. So we're going to do the same here. And we're going to cross this out. And this is going to be negative 2. Sounds about right, right? Now phosphorus. We want to find that in phosphorus pentachloride. Now P plus 5 chlorine atoms is equal to 0. X plus 5 times negative 1 is equal to 0. Therefore, if you're going to have 5 times negative 1, you're going to have 5 here equals to 0, right? So you want to get rid of the 5 on this side and keep the x. You're going to add 5 here, and you're going to add 5 here, and this goes. So therefore, you're going to have plus 5, because 0 plus 5 equals to plus 5. Sulfur. You're looking for sulfur here. So you have 1 sulfur, and you have 4 oxygens, and you have an overall charge of negative 2. So 4 times negative 2, which is the charge of oxygen, will give you negative 8. And x minus 8 is equal to negative 2. You want to get rid of the 8 on the left-hand side. So you're going to add it over here as well. This goes. So you're left with x equal to 2. Equals to 8 minus 2. And 8 minus 2 is equal to plus 6. Right? And now we have the nitrate anion. We're looking for N. So we have N plus 3 times O equals to negative 1. Because that's the overall charge right here. So N is over X plus 3 times negative 2 equals to negative 1. 3 times negative 2 is negative 6. You want to get rid of it here, so you add it, and you want to put it over here. Same thing you do on the left, you do on the right. So you're going to have 6 plus negative 1, which will give you a plus 5. That's the charge on your nitrogen. Now, this is for you to do. We have methane, CH4. I'd like you to let me know in the comment box below what the oxidation number of C is. Good night. Hope this helped. Study hard for your 6Cs.